contaminants cause corrosion. Corrosion causes leaks. You understand where we have to make sure that we protect all the metal surfaces and stuff inside all of our equipment. Moving right along. Right in front of you, big silver tubular thing. This is steam drum for this particular unit. This is what maintains the drum pressure in the boiler. Very important aspect of this boiler is your condensate comes in. You have non-condensables that are removed. You look over mid, you see a small plume. That is your non-condensables being removed so that you don't have to put a smaller boiler when you're making the unit. Okay? You have your stack over on the right-hand side. To the left, David alluded to being able to put chill water into the intake jar, make it cooler. This line to the right over here, to your left, my right, comes from chill water and is piped over to the intake up here, right up here. Follow me real quick. These are the lines that come in and out from that area. Okay? Actually, this will be even more interesting for y'all. Walk with me. Hands and toes inside the bus. Follow me the way down. We're just going to walk by the gas turbine. If you look directly above your head, you will see where the intake is right over here. Right in front of you is actually how compact this gas turbine engine really is. From here, right here, gas turbine engine that actually runs it is amazing. That much horsepower can be in this small boiler. Okay? You keep going along, you'll see the generator section right here on the back side as well. Do is we're going to look behind y'all over here. If you're curious about what this cylinder is, it is actually ammonia. That what makes this particular setup really special is you actually inject ammonia into the exhaust to increase the amount of emission in the environment. This particular gas turbine setup. Makes it really effective and keeps us in compliance. There are other types of injection systems. Ammonia seems to be one of the more efficient ones, and it helps maintain our NOx and our CO in a tolerable level. Press the button. Yeah. How are you gonna do that?
I was going to ask how do you have instruments for measuring the emission level?
Very much so. The question was, yes, we do. And for making those, I will actually show you what that is. We have it for this particular unit and our board. We have another board that is our backup, and I'll show you exactly where it is and how they kind of keep track of it. If you turn around and look behind you, this is actually where the natural gas comes in. So they actually had to drill from Texas Avenue to bring in a 600-pound natural gas line to here. Now, as it gets to here, it is broken down as needed throughout the plant for natural gas. Do you have any questions so far? Sometimes we put in additives for things like that. Is that a problem? There is a fuel conditioning skid that is attached to it to take care of some of that as well. So yes, we do ensure that we're getting the quality of gas because of fuel curves, mapping on the gas turbine. It has to meet a certain amount of, let's just say, BTUs.
That's right.
To be able to function properly with the particular mapping they have in place for this particular gas turbine. Now, in commissioning, there had to be some fine-tuning several times to get it right. So it does matter about what kind of gas we're getting in here, and we do make adjustments. We actually heat it up as well, and then do some conditioning as well to make sure that we have what we need to get it to run right. Right over my left shoulder is the dump condenser that David was talking about. We are able to create a false load if necessary with this dump condenser. I think it is rated for 120,000 pounds if necessary. And what basically happens is you have condensed water going through it from the tower, and you basically knock the temperature out of the steam and condense the steam. If we need to have a false load for something in the system though, we can dump 20-pound steam in here and generate a load, so to speak, because it's all about supply and demand when you deal with the 600-pound system, 60-pound system, and 20-pound system in this plant. Directly in front of you is our emergency backup generator as well. This emergency backup generator has gone through some different usage ideas. One of those usages right now is to supply power to the backup batteries, UPS system, to ensure that we will have power even in a loss of power on campus. And we're going to be shooting with a 0-volt startup when the right wires and switch gears are put in place so that we can start even if there's a blackout on campus. Any questions so far? That is affirmative. It is a diesel generator. We actually have 2 storage tanks on the back side that can feed, that we fill it up if necessary, and we could run as long as we needed to by opening some valves and turning on a pump and keeping it filled up so that we can run continuously if necessary. We'll go into this bus group area. Go ahead. What's the capacity on that generator? 1.3.
It's 1.25 megawatts or 1,500 kVA.
Okay, thank you.
So this, I'll go ahead and
By all
once again, this is one of our many sections of, this is a switchgear, metal clad switchgear manufactured by PAL. You can see all of our protection is Schweitzer's. This is literally just a communication processor. You'll see some of the information we get back in the control room. Here's some old school Basler bus differential relays. So this is, and then of course we have, even on this, you can see when we've upgraded our power meters. This also is a power meter, but we have an energy group that has power meters. You can see almost 3 levels of about 10 years of different meters as we've continually upgraded our meters on campus. So what I was saying, this is one section of gear. Directly above us is an identical section. On the other side of the plant is 2 first and second story sections of gear, and then of course we have these spread throughout campus. This bus just feeds the plant. The bus above goes out and feeds all the campus buildings. They're not tied together. Obviously the fault capacity, generation capacity of the generator is pretty large. So one of the biggest reasons I mentioned earlier is to reduce that fault capability, which is fundamentals. For years they used to run with everything tied together. So we decided to split it instead of putting reactors throughout the system.
I have a question. I have a question.
Go ahead.
Do you have a backup release? Because this looks like just a single release. The protection, is it just a single protection?
This is a single relay that has multiple functions.
Yes. What if it goes out of its faulty? What happens?
If this relay faults,
Yeah.
we have inventory ones. We have the program where we can pop one in less than an hour. So
It means that there is no redundancy.
on the relays,
Yeah.
if the relay fails, the breaker doesn't trip. We get an alarm, we come down, and we program the new one. They don't fail often. They're very good. But I think since I've been here, we've had maybe 3 failures. Normally it's the power supply that fails. So if a relay fails, there is the differential protection on the bus if it gets out of hand. Coordination of the relays. Can everybody hear me? I'm not pressing the button. Coordination of the relays has been one of my biggest challenges, to make sure that the relay settings get programmed as the system's been coordinated. Of course, every time you change it up, you have to redo the coordination. We actually had an incident where this breaker upstairs on a feeder about 1.5 years ago, there was a faulted section of cable out by Zachary, not Zachary, the building where Power Squared is at. There's a cable fault out there, and the breaker mechanically fell. The relay worked in this case, but the mechanical latch bound up so the breaker didn't trip. We actually had trip at the substation. So we probably could have had better coordination where I tripped the main here by taking it all the way up to the transformers. We almost lost the 138 kV transformer. I can't, I'll go ahead and speak. Can y'all hear me now? I can't emphasize the coordination, and this is what we're all about. So is the coordination. I like it. It gets tedious at times. I don't get to do as much as I used to. But if it's not properly coordinated, we almost lost a $2 million transformer. So because of it. So anyways, like I said, typically on one of these breakers you'll have 10 buildings, and we got breakers throughout the camp, Heldon Fells, other side of campus, and so forth.
One of the other things that y'all should be aware of, right over here is a motor control center, and we also have feeders that feed just the motor control centers. Well, what they do is they actually break down your voltage that you need, power that you need, and control various things. So on one motor control center, there might be 15 pieces of equipment that it actually takes care of. This particular one we've gotten away from using this one a lot. So this is one of the more emptier ones. But as you can see, it has an individual breakers for each piece of equipment. And these are very, very important. These are scattered all throughout the plant, because knowing where we're having a problem could actually help us determine if we're having a problem with the feeder, for instance. So knowing what's on those motor control centers also help. We're going to head that way.